Hi, ladies. I apologize that this is a little late. Luckily, it's going to be a short little video for you. Um, I thought this would be our last topic of this unit. There's actually one more little thing I want to talk about, and we're going to do that on Monday. So on Monday, we'll talk about that little topic. We'll do a little bit of review and start our practice exam. I will post the test also on Monday. Hopefully, we can get most of that practice exam done together on Monday. If not, we'll push into Wednesday, and you'll have all week to work on your test at home. If you need a little bit more time over break, I'm happy to give you that time as well. So we'll talk a little bit more about this on Monday, but let's get started. So we talked about the other day about graphs, and graphs start at the origin, or 0, 0, and have a constant of proportionality. They are directly proportional, right? However, we talked about sometimes lines don't start at 0, 0. Therefore, if it doesn't start at the origin, it does not represent a direct proportion. However, it's still a line. And again, this is kind of pushing us a little bit into that algebra curriculum, but I think it's important to talk about. So we talked about last time that lines, like I said, sometimes don't start at the origin. And we talked about slope, and we talked about how slope is change in y over change in x, right? So how much do you go up and over to get to the next point? Up, oops, up and over to the next point. So these are 2 points on the graph. How much do I go up and over to get from point A to point B? And that was simply just counting. We're going to look at the algebraic piece of this on Monday as well. Ooh, sounds like we have a busy Monday. But it's very simple. I think you guys will do great with it. So let's talk about the equation of a line. So a line is what we call slope, which we talked about the other day was our m, or our average rate of change, or it's the same thing as our constant of proportionality. How much do you go up and over to get to the next point? And it's the same for every point on the line. So our equation is y equals mx plus b, where m is our slope, and b is what we call our y-intercept. Now I want to just pause for a second. Remember we talked about when lines were directly proportional, they had this equation y equals kx, where k was our constant of proportionality, what you multiplied to get to, from point to point. However, k, aka constant of proportionality, and m, aka our slope, are the same thing. We just use slope when the line is not in proportion to each other. Now, a y-intercept, let's talk about that a little bit. Just watch this. I'm just going to use this graph because I don't have a graph to show you. But remember our lines before, when they started at 0, 0, they looked a little something like this. And they all, I know, had a different slope. But for the most part, say it was something like this. Okay. So it went through the origin. And for this one, imagine if it lines up a little bit better here. Up 1 over 1, up 1 over 1, up 1 over 1. So our constant of proportionality, right, we can see is up 1 over 1. Now, let's get rid of this. We're going to look at lines that do not start at 0. Oops, 0, 0. Let's get rid of these, right? So maybe it looks like something like this. So what we need to do now is we need to look at, first off, where is our y-intercept? And if you remember, this is your y-axis, right? So the y-intercept is where it hits the y-axis, right? It intercepts or hits right here. And then that's our starting point. And then we want to determine what our slope is, how much we're going up and over to get from point to point. All right, let's do an example here. We're only going to do a couple examples. Like I said, I'm going to try to keep this video short for you guys. Oh my goodness, look at all these arrows. I don't want those. see if I can get this arrow out of here. Let's do this. And delete. Okay, so let's look at our equation here. Graph this line. Y equals -4 over 5x plus 3. Now, I really quickly want to write out y equals mx plus b. Where m is our slope, our average rate of change, aka constant proportionality, right? How much do I go up, over, or down and over from point to point? And b is our y-intercept. Okay? So b, your y-intercept, is always like your starting point. So if they don't put numbers on the graph, you guys have to do that. So I'm just going to put a scale. Remember, as we go right, the numbers go up in the positive direction. Think about a number line. As we go up, obviously the numbers go up in the positive direction. 6, 7, 8, 9, 10. As we go down, they go into the negative direction. And as we go left, think about a number line. We're going into the negative direction. Okay. So our equation here tells us, again, b is your starting point. So if I look at my equation, b is the number that's not with x, right? It's just a number, it's just a point. So this one tells me that I'm starting at +3. So I'm going to not use yellow because I don't want to use yellow right now. Start at +3 and you put a dot. You go down 4 because it's -4. 1, 2, 3, 4. But then over 5. 1, 2, 3, 4, 5. And you put a dot. We are going to keep doing this until we can no longer fit the entire line on the graph. So ready? Down 1, 2, 3, 4. Over 1, 2, 3, 4, 5. It's a constant rate of change, right? Every point from point to point is going to go down 4 over 5, down 4 over 5. Unless, let's go up, and this is kind of what Sarah pointed out the other day. If I go up 4, one of them, if I go up, then I need to go left, right? Because I need one of them to go into the negative direction. So it wouldn't make sense if we went 1, 2, 3, 4 over 1, 2, 3, 4, 5. Oh, that doesn't look like a line to me. That would be like a almost like an inequality sign, right? So now we're going to go in the opposite direction. Count 1, 2, 3, 4 over 1, 2, 3, 4, 5. 1, 2, 3. Oh, crud. I can't fit anymore. That's okay. I'm going to finish the edge. And I'm just going to connect my points here. And we're going to put arrows on it. And we're going to talk about this a little bit when we get into some of the geometry stuff. The line goes left and right forever and ever and ever and ever and ever. But obviously, I won't make you do that. So we just put arrows to tell me that it goes this way and this way forever at the same rate. And that's how you graph a line that's not directly proportional. So you start at the y-intercept and then count for your slope. We have one more example here. We do. 2 more examples. Okay. So again, y equals mx plus b. B is our starting point. So this tells me I'm going to start at -2. And my slope, my m, tells me how much I go up and over. But I only see a 3 there. That's okay. It's really right 3 over 1. So up 3, 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 1, 2, 3. I know you're probably like, oh my goodness, that's annoying. Now we're going to go in the opposite direction. And again, 1, 2, 3 over 1. 2, 3 over 1. I'm going to connect it with a straight edge. Oops, that wasn't great, was it? And I'm going to make sure that I have arrows on both sides because it actually goes on forever and ever and ever. And that's how you graph the equation of a line. So you start at the y equal, you start your y intercept and you just count your slope. If it's a whole number, right, we just put it over 1. Because really 3 divided by 1 is 3. Let's do one more example here. Ooh, this is tricky. Okay. Whoops. Y equals mx plus b. So again, b is my starting point. So this tells me I'm going to start at 3, but I don't see a number in front of the x. Remember, if nothing's there, it's actually a 1. So it's a negative 1 over 1. So I'm going down 1, right 1, down 1, right 1, down 1, right 1. And you keep doing this, right? Until you can't go over anymore. Oops. There we go. I'm going to connect it with a straight edge as best as I can here. Oop, that's better. And make sure you have arrows on both sides. So just a really, really quick recap. Your B is the number at the end that has no variable with it, aka an x, right? So it's just a 3, it's just a 4, it's just a -2, it's just a 5, whatever it is. And that's your starting point of your line. That's your y-intercept. Look at that. It hits the y. That's where it hits the y-axis. Your slope tells me how much I go up and over or down and over, right? So if it's negative, your line should be going down because it's negative slope. If it's positive, your line should be going up because it's a positive slope. If it's a whole number like this, you can really put it over 1. So that would tell me I'm going up 5 over 1. If it was negative, I'd be going down 5 over 1. And that is it, okay? So we'll practice this a little bit more next week. And if you have any questions, bring them to class and let me know. But other than that, have a great weekend. Check your emails because I did do a bunch of grading this morning. So if there's anything that you have to redo, I did return that back to you. So take a look, work on some of that, and I will see you on Monday. Have a great weekend.